Hello, welcome to the Institute for the Study of Consciousness. I'm Harris Freeman. We're here with Arthur Young, the founder and president of the Institute, for one of a series of conversations in the nature of consciousness and the relationship between metaphysics and science. Our guest for the day is Fritjof Capra, a physicist at the University of California and author of the Tao of Physics. It turns out that Fritjof lives practically right around the corner, just a few blocks from the Institute. He and Arthur more often encounter each other as neighbors than they do as colleagues in a more formal setting. We're going to be discussing a number of issues today around the interface between consciousness and the methodology of science. And the first thing I'd like to go into is the appropriate scope for the kind of inquiry that we use the term science to designate. So, Fritjof, I'd like to ask you, is the term science, the concept science, something that we ought to be pushing and expanding as widely as possible to include all of inquiry? Or is it simply some well-defined subset of the kinds of inquiry that there are and ought to be working at filling in the boundaries and leaving it at that?
Well, I think it's useful to distinguish between different modes of inquiry. It's useful to distinguish between science, art, religion, philosophy, and so on. And therefore, I think it's useful to define science and to narrow down the approach when you talk about a scientific approach. Now, the question is, how shall we define it? And we could talk about how it was defined in the past and how it could be, how that definition could be expanded. But I don't think we should call any inquiry scientific. That, I think, just would take out the variety of life if you just pull everything together and don't distinguish.
Well, then, is there some kind of a metastructure that isn't science and isn't art and isn't religion, but that's something that we can talk about?
The way I see it is that there are various ways in which men and women have always attempted to understand the universe. And throughout the ages and in various cultures, they have developed various methods. One of these methods is science. And in the sense that we are using the term now, it's a method that has originated in the 17th century. When we talk now about science, we talk about that 17th century type of inquiry, and that could be expanded usefully. But then there are other methods, like the methods of painters, of dancers, of philosophers, of mystics, all kinds of inquiries. And I think it's important to realize that they are equally valid. And the scientism which I think we have to overcome, is to regard the scientific mode of inquiry and scientific knowledge as the only acceptable knowledge and the only valid knowledge. So that, for example, when government wants to ask some experts about a political decision, they would invariably ask scientists. They would not ask poets, but they should, to get a broader spectrum of human experience. But other than that, I'm very happy with having a well-defined term of science, scientific inquiry, and so on.
Arthur, we've been going about this over some period of time. I still kind of feel that your views are somewhat orthogonal to that.
Well, I always think of some other answer, which would be that I feel science is already encumbered with too much preconceived notion of what science is, and especially in pressing into the ultimate nature of things, it stumbles on something that's much more like the Tao than it is like science. And I think you could still preserve a distinction between the scientific method, but it begins to be a little less distinct than before, because these things may not be susceptible to the precise laws. And above all, I think science, in this assumption of out there-ness, is way off the
Well, maybe we
track.
should ask what science is and what...
I've been wanting to do that all day.
Yes.
Arthur, what's science?
I think it's the search for truth. I don't mean what defines a science. If you were going to employ them, then they might have to have a degree from Harvard or something. But science means knowledge, and
Right. Well,
it's not equivalent to wisdom. But when you said there are different, there's valid, let's say the poets, but you might have a great difficulty in getting agreement among the poets as to what should occur.
But would
So-
you call the poets scientists?
No, but I mean, the difficulty about getting opinions from these other areas is that they're not, the way science is, subject to this agreement. That's really one of its most powerful assets, and yet it's also a weakness.
Now, wait, I want to jump on this. If you're going to answer the question of what science is by saying that it's the search for truth, then I think you are saying that poetry and art and religion ought to be subsumed under the category of science, as science ought properly to be understood. And that's really the opposite of what Fritjof is saying, which is that science is the search for truth using one particular methodology to get at it.
And also I wouldn't say it's a search for truth. I think it's very important to... Well, I think the way in which Arthur talks about science is probably the original use of the term, from the Latin to know, but it has changed considerably, and the way I would like to use the term now is that it is an endeavor to understand the universe, a mode of inquiry, which is characterized by essentially two things. I've been thinking about this for a while now, and I've found that there are essentially two things that would satisfy me in calling an approach scientific. One is the empirical basis. It's based on, and then you can go on and can define, and you can see, you can distinguish between various sciences, of course. All science need not be the same. So then you can say you have an empirical approach. Well, I would say probably a systematic empirical approach in the sense of experiments, but not necessarily involving machines and so on. Like, you know, Zen meditation would be a systematic empirical approach too. So the empirical basis would be one thing, and that's commonly known as the scientific method. And then the other thing, which is generally not realized among non-scientists and even among people within the field of science, is the method of making models. That you describe or interpret your experience by more or less well-defined models. And these models, which are mathematical, verbal, but essentially rational models. And these models are necessarily limited and approximate due to the inherent limitations of the rational mind. And therefore, in my view, science can never be, well, it could be the search for truth, but science will never will never find truth, will never make statements about truth. And I wouldn't call it even the search for truth. Well, that's probably just a question of words. But,
Does the phrase the search for truth mean something substantially different than the search for knowledge?
yes.
Does it mean something substantially different to you, Arthur?
Well, I would let it stand at that, because I would reserve this higher truth, the word wisdom, and that I don't pretend to make prescriptions for it.
Wisdom is about choosing goals, and that's
Right. But of course, Bacon said that science could not deal with first causes, and presumably other philosophy and religion would deal with first causes. But what I find is that in order to thoroughly understand science, even within the findings, the empirical findings, that it's necessary to have a much larger view of what reality is than is currently held.
Oh, yes, I think I would agree
So
with that.
it's only in that sense that I would see that science had this wider, not so much, well, wider responsibility to, well, just, for example, relativity has been a great stimulus to the sort of metaphysical interpretation of facts, and it's stimulated ideas about cosmology. But I don't think that task is anywhere nearly completed. In fact, I think there's certain errors in relativity that have been extremely misleading. Now, I can't really call that scientific method, because such a theory might not be. On the other hand, you have Jung, who's a very fine psychologist, and he's quite empirical.
Yes, and he always insisted that,
Right.
that his endeavor was a science.
Right.
It's hard. It's really hard to decide whether you should consider the Jungian archetypes to be at the same level of abstraction as what you normally think of as scientific law.
Well, certainly, in one sense, they're empirical, in another sense, they're not. But you can hardly ignore them.
To your pearl.
Well, certainly I would call analytic psychology a science, because it satisfies my criteria. It's based on an empirical approach, and it makes models. It talks about synchronicity, archetypes, animus, anima, all kinds of things, libido, all kinds
Right.
of models. And then you can talk about exact sciences, so you can distinguish between the degree of preciseness in the model making. For instance, you could ask, do you need mathematics to be scientific? And I don't think you do. I think you can have a perfect science without using any mathematics. But then there are other sciences that use mathematics very successfully. And or you can ask, do you need quantification to talk about the science? And again, you could maybe distinguish between sciences that quantify and other sciences that don't quantify. But I think the model, making a model is very crucial. And that's in distinction to truth. Truth is not a model. Truth is that's really it. Once you recognize the truth, that's it.
Still not happy.
Huh?
There's something boring from within here. If you were, well, there's a knowledge, could I use the term meta-knowledge? That's been so abused that I don't like to use it at all. But there are a whole lot of, well, there are certain things that if I had my druthers, I'd take the scientist and rub his nose in them because it concerns him. It isn't that I'm trying to introduce him to ESP forcefully or something like that. I'm trying to get him to see some sort of light that would be a great help to his own business.
Concerns him as a physicist?
Well, you keep getting narrow, but that, suppose the uncertainty principle hadn't been discovered. Then, and suppose some advanced thinker had predicted the uncertainty principle. And then suppose that the scientist said, well, that's outside the scientific method. We're not going to look, we have nothing to do with uncertainty, our quest is certainty, and period. Then you would get the predicament that I think science is in now with certain things they're choosing not to look at.
You know what I sense, Arthur, is that there is a value judgment implied, that science is better than anything else. For me, it's not, there's nothing wrong with some thinker suggesting something.
Wouldn't you agree that the uncertainty principle has been important to quantum physics?
Oh yes, sure.
Well, and I'm saying that there are other things that are important.
Yes. No, I agree
physics.
with everything you say, except that a scientist could well accept a suggestion coming from outside science, acknowledging that it's a suggestion that had not been made in a scientific framework, but that is nevertheless valid. And that's where we have to get to interplay between...
We're at a difficult impasse here. I mean, we were talking before you came about strategy, politics, but it was all directed at how could we get either a more tolerant or a more inquisitive attitude towards science about these things about consciousness that currently more or less have to be banned.
That's right. But that has nothing to do with the methodology of science. That has to do with a certain science. This has to do with the fact that psychologists, who are the professionals of consciousness in a sense, adhere to a Newtonian conceptual framework.
Yeah.
And in this Newtonian conceptual framework, there is no consciousness. If you take the Skinnerian type, the behaviorist type.
Well, what would you suggest then as, let us say, strategy, policy, what have you?
Well, I'm actually writing a book about this, which will suggest to make them aware that there are even physicists now talking about consciousness.
Yeah.
So that consciousness is a very, acceptable phenomenon within the realms of science. That in order to be scientific, you don't have to be Newtonian.
Yes.
I think that's the crucial point. That psychologists or economists are a good other example. They always want to be
waiting with bated breath, but there has been this. Well, we were talking to someone about. I was talking about Gardner, Henry Margenau, who is a really good scientist. But when I last heard him, he had moved over to the statistics camp from the determinism camp, and now for him everything was statistics. I said, "Do you mean to say you think the desk might suddenly jump out the window?" He said, "Yes, there's a possibility."
It just might.
Just might.
Yeah.
Now, of course, I know that he felt that possibility to be very, very small, but the fact that he couldn't make a commitment to the Newtonian mechanics without being inconsistent with his commitments to statistics, to me is a shortage of a vocabulary. I mean, you need to recognize these different domains, and it's an extension of that to go beyond even statistics and recognize that the improbable has a role. This reminds me of a question that I don't know whether it's on the list, and maybe you'd like to consider it.
Well, go ahead and bring it up.
The question of what is life? And I wonder that science can answer this question the way it currently anchors itself to whatever these things are.
No.
Well, what would an answer? What is life?
Life.
Yeah. Well, one argument would let's talk about what an answer to that question would look like. One argument says that an answer to that question would be a fairly effective rule for going around and looking at things and
telling whether they're alive.
Telling whether they're alive.
I think those rules exist.
Okay, but you think that a completely effective rule such as that is not an answer to the question, what is life?
No. In other words, if I were to say life is negative entropy, and that's a fairly effective distinction, it still doesn't explain how the law of entropy is violated in the case of life. Because entropy is at least has the status of a law. It's not quite a deductive principle.
Right.
Well, this is the type of question that biologists at the moment have great trouble in answering because of the fact that they stick to this Newtonian Cartesian framework.
And I think
they see life as a thing, but it's not a thing. But there are others that apply a systems approach to the question, and that would say that life is a certain process with certain characteristics, and then they would list 5 or 6 characteristics, and that comes much closer. But it's not a straight definition.
Right.
I'm really object. I'm really unsatisfied with questions of the form "what is."
Well,
I think it's just a semantic trap.
I think that's one of the difficult. I don't agree with you, but
I know.
I think that
I know you don't.
I found any number of biologist books that would state right at the beginning, you must not ask questions like what is life, what is the purpose of life, why are we here, and so forth. And then they would parade the usual routine about the falsifiable hypothesis and all that. And of course I've grown up with all that, and it's fun, and I think it's had its usefulness. And now it's time to turn to those questions that I don't think are
so
meaningless.
Yeah.
See, I'm a lot more willing to accept questions of the form, what ought I do? What is to be done? What should I want?
That's essentially a religious or moral problem. And if you don't like, is it because of the phrasing that you don't like the question, what is life?
Well, you see, there's a practical consequence.
I guess so.
You know, the question, what is life, may not have an answer within the scientific framework, but nevertheless it's useful to ask, because just one example would be a closely related question, what is health? Now, if you really study the question, what is health, you find that it leads you back to what is life. You cannot give a definition of health unless you...
We found the same thing about evolution. Right? But if you ask, if you really make a serious attempt to find out what life is, you can account for evolution.
Yeah. Now, if I bring this health question up because it's not asked in medical education, and that prevents doctors from being efficient.
Right.
No.
Right.
So it's
Let's go back to your objection.
For some reason, I'm totally satisfied with the question, what is life like? And totally
yes, but what is
leery
life
of
like
what is life.
is descriptive.
Yes, I guess that's why.
And the point of theoretical science is that it can provide more than a description. It provides a deductive thing for explaining how and why it works. I mean, it isn't sufficient to describe an automobile. You must be able to make one. And I'm not saying you have to make life right away, but I think ultimately we'll have to do that as we evolve to higher stages. But let me take, for example, chemistry, where it's not only a description of insulin as such and such a chemical, but they can synthesize it. They're making good progress synthesizing many otherwise considered impossible chemicals. And I would say that's a genuine
But life may not be of that nature. You may never be able to synthesize a living organism. Actually, I believe you won't be.
Well, possibly not, but still you could explain how the organism synthesizes. In other words, it's not your business.
You could try. I take the questions like what is life in the scientific context very much as what is life like. For me, there's very little. As a scientist, this is the same for me. There's very little difference. Then, as a human being, experiencing life and being in awe of life, I take the question, what is life, in a very different sense.
Well, you wouldn't object to that sense.
No.
Well, I'm still not satisfied myself because I don't feel that to answer what is life, I have to be able to create life.
Well, that's what you just implied before when you talked about the car and the insulin.
Look at it the other way. If you could create life.
Actually, a mother does create life, but she can't explain it.
Right. But if you could build it with your hands, would that constitute knowing what it is?
Well, a lot of biologists are now creating new life forms by mixing genes in the chromosomes and so on. But again, that's to me only one step away from a gardener who grafts a different stem on. Yeah, he's not really understanding it. He's just using the process and redirecting it.
That's right.
But to me, there's a theoretical problem there of the greatest interest. And I'm sorry I can't get more people to be inquisitive about it. This gets back into the question of someone accused me of trying to answer questions nobody was answering. Mm-hmm. And well, I took that very much to heart and tried to wait. And then I found that people wouldn't ask questions unless they had the answer. And then this led to a different way of teaching, of getting people to ask questions. And I found that very fruitful because then they could answer their own questions.
Mm-hmm. Yes. Fritjof, do you want to take a break? Mm-hmm. Okay, we'll take a break now and we'll come back and answer some other unasked questions about the nature of light later.
Well, I hope I didn't interrupt by putting that other question.
Okay, and now it's time for another question. So,
Not quite.
okay. So speaking of questions, I want to ask you this question about the nature of light in your theory, or your ideas about the nature of light. The question is there any reason really for signaling out photons as being unique among all other particles and assigning a special role to them that somehow relates to purpose and freedom of will?
Well, there are a number of reasons. The one that first brought it into place as number one was because it was the end of the line. I followed, molecules are made out of atoms, atoms are made out of protons and electrons and electrons can be created out of photons, pair creation is known as. Now I've had other people differ and say, well, it can work the other way too, which moves me to another reason, that photons have unit spin and electrons and protons have half spin. And even that got a negative response because the German physicist said, well, I'd rather think of two halves making a whole than a whole making two halves, which begins to distinguish my theory from others, that I'd prefer to begin with wholeness and think of properties as coming about because they're parts of a whole. To take a ridiculous example, let's say a string has a middle and two ends. But if you were to remove the ends, they wouldn't retain the property of being ends. They would themselves have ends and middle. So there are a great many properties that come about because of their relationship to the whole. So therefore, I would think that the wholeness is primary and unit spin is before half spin. But that doesn't exhaust. I don't know whether you want to hear any more. The fact that the photon or unit of light travels at the speed of light, which no physical matter can reach, gives it a distinction that is perfectly commensurate with assigning it the role of spirit, because remember in the Bible it says God created a firmament to separate the water above from the water below, and using symbolism, as I do, to translate, water means energy, so these were the higher from the lower energies. And the energies of the lower can be condensed into matter, and matter cannot go at the speed of light. So the firmament becomes the speed of light.
The firmament?
God created a firmament to separate the above from the below. Now we know there's no firmament out there because you go right out into the sky as far as you want.
There's there's a lot of mythological argument, spiritual argument for looking at,
well, maybe we can
at light as primary.
bypass that. But
Well, no, I'd like to hear you speak to it.
well, it was I've used that to a British physicist. I thought I'd dreamed up the idea. He first had to satisfy himself that I knew my relativity, so I went through a long catechism explaining so that he was satisfied about my relativity knowledge. And then I thought I'd pull this whammy and said I've figured out that the firmament is the speed of light. And instead of being surprised, he said, well, that's what St. Basil said. So I was put in my place, and sure enough, 370. I have it in the book, so I won't quote it here. But Basil made a comment that anticipated the fact that time does not exist in the realm of light. And I think it's much more profound than most of the things Aristotle said.
Aristotle. Fritjof, do you see anything philosophically special about light as a physical object?
Yes, I'm not sure whether I'm supposed to comment on everything that is said, or whether my silence would imply agreement with everything that he said. I hope not, because there are an awful lot of concepts coming up. And for one thing, I don't believe there's a God who created the universe, and it just goes on into a lot of metaphysical concepts that we might differ on. But so I think the best would be if I just gave my view of the special nature of photons, because I also believe that photons have a very special nature. And that's actually an idea that is due to Jeffrey Chu and not to myself. And what he points out is the following. When we do science, especially in our field in physics, when we do science, we observe matter and various processes. And to do that, we need electromagnetism. Light is just one special form of electromagnetism, so we can talk in more general. When we say photon, we can also say electromagnetism. Electromagnetism is absolutely crucial for the process of observation, and it is an essential ingredient of our method of looking at the world, of our method of observation and measurement. Therefore, if you want to explain the nature of electromagnetism, that means you want to explain your way of looking at things in the language that implies that way. And therefore, Chu says we will never understand photons and electromagnetism in the scientific framework. And I think that singles out the photon among all other particles, because there are other, as you know, there are other particles with spin 1, there are other particles that go at the speed of light, although the neutrino might not have exactly zero mass.
Well, I've had that one about the bosons, but the bosons turned out to be all hypothetical except for light. I thought the pion was...
I'm talking about the neutrino. I'm talking about the neutrino, which is a particle of supposedly of zero mass. Yes, has spin 1/2, but also travels at the speed of light, supposedly. So there are particles that have spin 1 that are other than the photon. There are particles that travel at the speed of light.
Well, that's what I was addressing myself, whether there were particles other particles that had spin 1. They referred to gravitons and some other things that haven't been verified, so I don't buy that.
No, but there are the mesons. There are mesons.
Which meson? The pi meson?
That has spin 0, but there's the rho, and there's a whole number of spin 1 mesons. There are 8, in fact. The rho and the phi and the eta. And there's well-known, they're called vector mesons.
Well, they weren't listed in a list of bosons that I consulted for the purpose of answering this point. The rho meson, that's a new one on me.
Yeah.
Well, these exotic particles that last for a billionth of a second, I have frankly not...
That's right, they're all unstable.
Yeah.
They're unstable. But I think this close connection, this inextricable connection of electromagnetism with the process of observation.
Well, I agree with that 100%. In fact, I say in the book that for attempt to see a photon is for the eye to see itself. It's the photon is seeing, it isn't something seen.
Yes.
And just because of that, it has this special quality.
And you know, Arthur, this is very funny. When you ask particle physicists, the majority of particle physicists, what kind of processes do they understand best? They would say electromagnetism. Because of this very special property of the force, electromagnetic force being very small, or the fine structure constant, technically speaking, being very small.
You mean small compared to the strong force?
Yes, and compared to 1 also. And so...
It's just enormous compared to gravitation.
Yes, right, but compared to the strong force.
Well...
And therefore they can do what is called a perturbation approach, and they can have a perturbation expansion, which works very well. But that does not give them a fuller understanding of what electromagnetism is.
Well, I think that's too technical. I have a few things to say on that myself.
It is. It's getting a bit technical.
At any rate, I agree with Fritjof, so we don't need to...
Okay, well, why don't we move into this sort of a wide area of talking about particles versus forces in terms of which one is a more fundamental way of... Which one is a more fundamental construct?
Well, I'm not going to do so well there, but I'll struggle.
Okay.
Maybe I could start with that.
Certainly, why don't you take that?
That's my field. I think the point to realize is that forces and objects are classical concepts. Those are Newtonian concepts. And whether you like it or not, whenever you use the term force, you use it in a Newtonian or semi-Newtonian sense. Or at least maybe you don't use it in that way, but people will understand it in that way. And therefore, in particle physics, we don't use these terms any longer. There are, of course, more or less Newtonian people, philosophically speaking, also in particle physics. But the most holistic or systemic approaches would say that there's a network of events, a network of interrelated events. And there are various types of interrelations. And particles are one special type of interrelations. And these interrelations, you can also call them the forces, but that introduces the classical term. So we talk about forces, we talk about interactions rather than forces. And among these interactions, there are various types, and particles represent a special type.
Well, that's okay with me. My quarrel is with calling these fundamental particles, overlooking the fact that they have no identity. And you have a number of reasons in addition, but I focus on that lack of identity because I think it has cosmological significance. I draw a great deal of, you might say, mileage out of the fact that identity only emerges as a sort of constructed principle, doesn't it? And that was my only difficulty or complaint about your book, that you kept referring to atomic physics when you meant subatomic physics. Mm-hmm. Because I grew up in atomic physics day, and everything was neatly laid out, and there was no really reason for faulting it for being neat. I mean, you could predict exactly where the lines of the hydrogen spectrum would fall, and this is characteristic of atoms as distinguished from particles, and this is a keystone of my theory, that these two kinds of things.
Yes, there seems to be a real threshold when you go inside the atom. That's a major
it's a category
threshold.
shift, and I constantly recur to electrons and the distinction between electrons and atoms to be able to use this category shift when I'm talking about other things, such as the difference between feelings and concepts.
Right. I guess atom originally meant something that was indivisible, and it's come to mean something that's divisible, but if you start dividing it, you're going to screw up your concepts of
introduces
everyday
a
life.
topic that I'm curious to hear from Fritjof. It may not be on your list.
Let's go with it anyway, that's no problem.
If you get into this area at all, the esoteric things, you have to come to grips with the question of reincarnation. And this says, well, the soul is not mortal. And I've found one way to answer this question is not so much to try to prove that it's immortal, but ask what are the criteria for mortality. And then you get a very interesting output, because the things that can be destroyed are the things that can be constructed. So if you take something simple, like the electron, which it cannot be destroyed, whereas the atom, which is constructed out of electrons and protons, can be taken apart. Now, of course, there's still a larger kind of thing which would revert the electron to primordial light, but I'm talking about a category shift, a jump.
So your argument for reincarnation is that
substance, which is of the nature of energy, cannot be destroyed.
Well, I would say that when you talk about material patterns, you have patterns of energy which can be rearranged.
Right,
so
but the patterns are constructs, you see, from my point of view.
Right, I agree. Now, with regard to reincarnation, I think that two questions. I don't think that a leaning towards or an interest in spirituality forces you to accept reincarnation. I think it makes you aware that we are certain patterns, and when we die, we dissolve, and death is not the end, and we dissolve into
what
larger
is it
patterns.
that
But from then on, you can ask the question of a reincarnation, that is, of a reformation of the individual pattern. And that is a question I've never understood. If there is no individuality, as the Buddhists say, if there is no ego, what is reincarnated?
That's been a problem I've worked on.
This is exactly the terms that I've always thought of this issue in. Yeah. It's much easier to accept the notion of incarnation, in the sense that we're each an incarnation of the all. And then the question becomes, well, but suppose you have two incarnations of the all, two spirits, and one is alive at a later point in historical time than the other. And suppose that there's some sort of unique information channel that connects the one that's alive at the subsequent time to the one alive at the previous time. And you're absolutely sure of this, and it's a unique information channel that's not available to any other two souls. Is that a sufficient criteria for saying that the second of these is a reincarnation of the first?
No.
It's not?
No. Because if you believe Jung, then you can tune into the collective unconscious and get all kinds of information. And
right, no, but I said assuming that there's a unique information channel, these two particular incarnations have this property that the memories of one are available to the other.
Well, you could say, you could say. You could call that reincarnation if you wanted to, I guess.
You can't make an experiment that proves anything. That's why I've given that up.
Right.
But I have a
you can make one, but you can't come back to tell everybody else.
Well, I mean, it won't prove it to somebody else.
Right.
Because even if I can identify some Phoenician in the first century, and I can demonstrate that I have complete access to all his memories, one explanatory hypothesis is that I'm the reincarnation of him, and the other is that I just have a telepathic, clairvoyant link to him, and you'll never be able to choose between those on the basis of evidence.
Well, that was the kind of thing I had to recognize right at the beginning, and this takes me back 25 years. There's no use trying to make empirical tests or any kind of test to prove something that is not within the belief system of people you're talking to. In fact, I couldn't even prove it to myself. But I do point out that the reason I wrote that elaborate theory of the universe, of evolution, and each step of each evolution leading to the next, is to demonstrate a continuity, and not only to demonstrate reincarnation of persons as men and women, but continuity through animals, vegetables, and so on. In other words, to be an animal, you can't just start at the beginning. You have to go through this routine that constitutes being plants and learn cellular organization and really get it down cold before you can then put into that cellular organization the animating principle which characterizes animals and have it move about.
Now, this is something about your theory that I don't understand. Are you saying that at some time in the history of a particular animal, there was a phase in which it was a plant?
Oh, no. I'm saying that before the animal was an animal at all, it was a plant. And it learned. But I can't prove that, any more than I could prove it. But I can show that if I look at the whole sweep of evolution in these terms, it makes much more sense than if I assume that Harris Freeman arose, 50 years, 40 years ago, boom. It's incomprehensible. You can start, my favorite thing is Mozart, who wrote symphonies at 7 and was copied down the Mass in the church at 4. Well, all kinds of fantastic. Mm-hmm. And to me, that implies many lifetimes of knowing music and learning it greater and greater Fritz Kreisler. Most musicians have to practice a great deal, 6 hours a day. Fritz Kreisler never practiced, told him, leave the violin in the drawer for 6 months, pick it up and walk into the symphony and play it. But
Arthur, do you distinguish between animals and plants and things like that? I'm a little uncomfortable with that.
The whole thing is very, very ordered. And I don't know whether you want to talk about that, but I can't very well talk about it without saying that this is another way to proceed rather than to try to convince someone on the basis of, say, Joan Grant wrote her past lives or something like that. Well, to throw it back, either to Harris or to Fritjof, do you think you can explain the phenomena of Fritjof or Harris or Mozart from scratch less than 50 years ago? I don't know, 50 plus or minus
no, of course,
75.
No.
Now, it's not just your character that needs explanation, but this whole repertoire of being able to run the organism involving trillions of cells. Each cell more complicated than General Motors.
Yeah, but I mean, we don't have to talk about evolution anymore. That's pretty well accepted by now. And
what's accepted?
The fact of evolution, of biological evolution.
Well, that wouldn't account for you, Fritjof, or me being different. They would say it came from your DNA, and I don't accept that at all. The DNA is the vehicle, and that's it does account for the vehicle, just the way if you buy a Ford car, you can account for it by the blueprints in Detroit. But the habits of the driver are not due to the blueprint.
Right. Well, to the extent that you directed that question to me, the answer is, I really don't know.
Yeah. Well, it's the kind of question I think we ought to be asking, and it's science is sort of preventing us from answering instead of helping us.
Okay. Well, I'd like to bring this to a conclusion, at least before we have a break and go on. So why don't we do that now and then look at how we can help science to help us in just a few minutes. The next subject area I'd like to move the discussion into has to do with free will and choice. Once upon a time in the heyday of Newtonian physics, it was a fairly common understanding or common prejudice that the universe worked like clockwork and there just was no room whatsoever for free will. At least some interpreters of science argued that. Since that time, we've had the breakdown of classical physics and the emergence of the new physics. And one of the features of the new physics is the principle of uncertainty. And at least a number of philosophers and some scientists have argued that the uncertainty in physical phenomena has sort of created a hole whereby free will can get back into the universe. And I'd like to talk about that. I'd like to hear both your views on the question of whether there is any relationship between the quantum of action and uncertainty as a physical entity and free will as a philosophical concept.
Well, I've never been impressed by these arguments that the uncertainty principle opens the door to free will. These usually, or very often, these arguments are advanced by people who don't really understand the uncertainty principle. And I believe that there is a room for free will, but it's not in the way that these arguments would have it. I could just in 2 minutes give you sort of my encapsulated
Sure,
view
why don't you do that?
Well, essentially, I see free will as a concept like substance or personal identity, ego, things like that, the self, which are approximate concepts, which are very useful in many circumstances, but ultimately dissolve when you go to a wider point of view. Now, as far as free will is concerned, I see the notion useful when you distinguish between what is inside you and what is outside of you. I would say that I'm not free if somebody forces me to do something. I would say I'm free if the impulse for doing something comes from within me. But then if you look within and say, where does the impulse come from? And you start talking about genetics and you start talking about all kinds of connections with the rest of the universe, to the extent that the self dissolves into the universe as a whole, then the question of free will becomes really meaningless and sort of dissolves with the broader point of view. So I see it as a limited concept which is very useful, and which is typically, of course, a Western concept, coming from the mind-body problem and all that. It's not an Eastern concept at all, as far as I know.
Arthur, from my reading of your work, especially the very nitty-gritty stuff about the turn, I get the impression that you are one of the people who very much feels that there is a connection, which I do also, but I'd like to hear, once again, your words on it.
May I just interject that when I say there's no connection between the uncertainty principle and free will, I don't mean that in an absolute sense. Since reality is essentially interrelated, there is a connection between everything and everything.
Certainly.
And I can talk about the connections I see between the uncertainty principle and free will, but it's not the connection that I have so far heard.
Well,
but I don't know Arthur Young's views on that. So.
I don't know whether to take the time, but I'm curious to know about these scientists who have said it, because every time I bring it up, they say, oh, that was dropped long ago. Now, there was some effort on Eddington's part to do so, and others have not given it much consideration. And in general, the reason is that the magnitude of the energy involved is much too small, but even to lift your finger.
But, you see, if we assume that, that lifting your finger is a classic mystery. Mm-hmm. You know, how do you decide to lift your finger and then lift your finger? Well, presumably someplace way at the back of the nervous system, or at the most inside of the nervous system, there's a little finger lifting switch. And if that switch is light enough to be easily manipulated telekinetically by your mind, that solves the problem of how the mind...
Well, we realize that that energy is very small.
Very, very small.
In fact, the only person that I know that does advocate free will as a quantum window free will interpretation is Walker. That's his name. He says it occurs at the neurons, but he has the difficulty that the neuron energy is rather one order of magnitude that's over 10 times greater than is available from the uncertainty.
What occurs at the neurons?
This interface between mind and matter.
But that doesn't...
The switch that Harris was referring to.
Well, how does that relate to the concept of free will?
Well, that is the place where something could swing the switch on or off, which would lift your finger.
Yeah, but that still doesn't change anything in the fact that your decision to do it is determined by all kinds of other things.
Oh, no.
You're not free in deciding that if you really follow up the various
If you want
strands.
to assume that the decision is not free, you can do so, but you can't prove that, you see. I think we could profitably shift the ground, but just to finish the sentence about Walker, he has to resort to tunneling to get the necessary energy. In other words, it's way off the center of the Gaussian distribution curve to get enough energy to flip this switch. And I say that that's the wrong place for it. Lots of life forms don't even have neurons, so you have to go back, consider single-cell creatures, which presumably have no nervous system. And there, the energy required is that which would change a bond, presumably in the DNA molecule. I can't say precisely where it is, but if it can change a bond, then it's enough to do the trick. And the fact that life is very sensitive to temperature indicates that something is critical about this range of temperature. For mammals, it's very narrow, especially when you consider that, let's say 98, which is normal, and a few degrees up or down, and you're a fever or dead. And it's not just 2 parts in 98, it's 2 parts in 98 plus 453, because you have to measure from absolute zero.
Right.
So it's much less than 1% temperature range over which life is possible for mammals. Now, that is an indication that there's something critical about this place where the energy is free. Well, if I can pass on, then I'd like to go to this thing I threw at you the last time we met at the restaurant. What do you think of the third derivative as control?
Oh, so we're getting off free will, at least temporarily.
No, I think it's the missing link in my
I see. Well, the third derivative is a mathematical construct, a mathematical operation. You have derivatives, you can go and differentiate a function, and you do one differentiation, you have the first derivative, you have the second, the third, you can have an arbitrary number of derivatives in mathematics. I suppose what you're asking is what's useful about the third derivative? I guess we're cut off.
What do we do? Wait?
I think we're cut off. Huh?
Fiat Lux.
So I guess I have to retrace my steps.
I guess you'll have to retrace that.
Yes.
But I don't think it's too necessary to review what the derivatives are.
No.
I mean, Arthur.
Or if you do, say the acceleration, velocity, acceleration.
Yes.
Why don't you start over delineating the various derivatives, but not quite yet, when Laney cues you.
Now, you're bringing up a term which is a mathematical operation, a derivative, and you can have the first, second, third, and so on, and you can have any number of derivatives in mathematics. And I suppose the question is, are they useful in physics or any other mathematical science for the description of reality? Now, in physics, traditionally, one example would be a derivative of distance by time, and the first derivative would be the velocity, and the second would be the acceleration. And I don't know of any instance where the third is used. That doesn't mean it isn't useful. I just want to mention one thing, and that is that in this particle physics that we talked about before, this network of interrelations, we don't use derivatives at all because we don't have equations of motion. See, these derivatives are always characteristic of equations of motion, which are sort of a semi-classical concept, because you need something that moves. You have an object, and then the object moves, and you describe that by the equation of motion. If you don't deal with objects any longer, then you don't deal with equations of motion. You still deal with equations, but they're not equations of motion. And so, also from that point of view, I just haven't come across any third derivatives.
Well,
except in mathematics.
I didn't want to put you on the spot, but I'm having a hard time getting some agreement from physicists on this elementary point of physics, which is that the third derivative is control. And you do it every day when you drive your car. You change, you slow down, or you speed up, both of which are changing the acceleration. And even steering is a change of the direction of acceleration.
I was really struck by the argument that you can't change velocity directly. that all you can do is
Right.
change acceleration.
So what
Well,
you
you can't even change position
so what you
directly
mean
except
is-
through this chain of causation which stems back to control.
So you're starting with a sort of engineering type definition and say, in engineering terms, the third derivative can be identified with control, and that's a useful identification.
In fact, it's used in aeronautics, and as we won't find it in the physics book.
Okay. Now, if the matter rested there, you wouldn't bring it up tonight, I suppose.
No, but yes, I would.
Because, whether something is interesting for engineers in a certain...
nothing rests for me, because I always want to
Right.
interpret it.
Right. So what are the ramifications that you see?
Well, it seems very simple that if you're talking about free will, you have to be able to control. This thing you dreamed up, this switch that would lift your finger, that's the control function. And I make my favorite routine, which is lost on most of the students, is to show that when you introduce, let me go back. I would first place these derivatives, position, velocity, acceleration, and control, as 4 quadrants of a circle, 4 points.
Okay.
Now, you can think of control as going 3/4 around the circle, because you haven't made the last point.
Yeah.
Now, if we start out with a physical universe, which is granted, pi, 4/3 pi r cubed, and then you multiply it by this control function, which is 3/4 of 2 pi, 3/4 of a circle, so it's 3/2 pi. 3/2 pi times 4/3 pi is 2 pi squared. 2 pi squared is the volume of the Einstein-Eddington universe. Now, this is one way to bring out that the difference between what they call the hypersphere, in other words, the Einstein-Eddington universe, and the normal sphere, is that the former is the result of conscious control, consciousness.
I think I get mixed up here. First you talk about a certain definition of control, and that I think any physicist will accept, that if you say it's useful in a certain engineering context, why not call it control? Then you say you will put these on a circle. Now you can put apples or pears or anything on the circle, and
well,
you can
it's
do
a
your
custom
dimensional
with
analysis.
the trigonometric functions, for example.
Oh, I see. You didn't
Well,
mention trigonometric functions.
Well,
so
because that's a special case, but
so in the case where you deal with trigonometric functions,
yeah,
you can use this well-known circle.
actually there are other reasons, but I'm trying to temper the wind of the short hand.
Now, can I try to understand? You introduce the term control, then you say, let's apply this to trigonometric functions, and then you say you have certain dimensional arguments which you can relate to the dimensions of the universe as a whole, or to the shape, and therefore you say control is relevant to cosmology. Would that be sort of the...
Right. Well, the thing should be developed and brought out more carefully, just to make sure I'm not violating any rules.
Yeah. Now, one thing that bothers me a little is that control, I can imagine all kinds of controls, like switches, which have nothing to do with velocity or
No, but
or
let us
acceleration.
take a motion of a moving body in space.
Yes.
And you're pursuing another airplane, shall we say. And the airplane sweeps around to the right. Well, you can steer your plane so you can follow him. The airplane speeds up,
Yes,
you can follow him.
Yes.
In other words, the control derivative, the third derivative, is adequate to duplicate any motion.
I see. Yeah.
Now, this is important because the next step, and this is even more rejected, is that you return to the starting point, in other words, to distance. You ask yourself, what controls control? What controls you when you drive your car? Well, when you get to your destination, you stop. Or if something walks in front of you, something having a position, you steer around it. In other words, position controls control, and the thing that clinches it is target-seeking missile. The missile is controlled with some tail surface or something.
You almost want to argue that the fourth derivative turns out to be just position.
I do argue that. Thank you.
But in you restrict
But is it
yourself.
really, mathematically?
Well, it's never been really investigated. Now, you can think of higher derivatives on up, but I would think you could simplify physics by recognizing that the fourth derivative is a return. And it's true for all the trigonometric functions. It's true for motion. If you apply it to some arbitrary, curious curve like the Gaussian distribution curve, it isn't true, but it's true at the origin. You get the same pattern repeating as you get to the fourth derivative. But that's technical again.
But I think you're restricting yourself to a very specific phenomenon, dealing with velocity, acceleration, and so on. The term control is much broader, isn't it?
Well, I would say that so is velocity. This is what I show in the geometry of meaning. Aristotle's notion of change is more what I'm referring to than just velocity.
So you're saying that your terminology would apply to any rate of change,
any
rate of change of that change, and so
Not
on.
just rate of change of position.
I see.
But
well, you have to. The acceleration is two rate of change of position, and the acceleration is a third.
right. But if we looked like at if we didn't want to just limit ourselves to talking about change in position, if we had some kind of a neural network that was changing through lots of states, we could identify the second derivative with the rate at which it changed through various states.
I'm not sure of that. I wouldn't want to commit myself to that. I might get in trouble. But I'm talking about what's really better referred to as the phase dimension, that I can control things through phase. And these points on the circle, another version of them is that they're phase. Still another is that they're points in the learning cycle. A point where you start something, where you react, where you observe, and where you control. And I think this is fairly clearly established. So in that sense, again, I can use control as 3/4 of this total cycle. Then you can say it's a phase relationship, and you get into something like jiu-jitsu, where instead of opposing your opponent or running away from your opponent, you throw him sideways as a phase relation which is equivalent to timing. And then that enables me to broaden this out into timing, which is partly an answer to your question of how does the free will operate. It operates through this phase, and the energy required is minimal provided you're at the level of the electron bond. And I would assume that that's the place to start anyway, because that's where you and I started when we were first one cell fertilized. We grew out of a single fertilized cell by action of this principle. Therefore, we can move the thing around.
I'm trying to formulate the right question here. Your reaction is that we're just, more or less, that we're just talking about science in a context where we shouldn't be talking about science.
No, that's not. No, I'm saying that I see these arguments dealing with very specific situations, with first of all, change of velocity and things like that. But then you have to have a cyclical process. Otherwise, that whole circle business wouldn't apply.
Well, I think all life is a cyclical process. Yes. You see, this whole notion of vibration is a cyclical process. And that brings in the next step of what is consciousness. I would currently define it as awareness within the time range of that cycle. In other words, consciousness of an elephant wouldn't be capable of dealing with the vibration of an atom at some 10 to the 15th per second. But it would be conscious of the life cycle of an elephant. Nor would it be able to function intelligently in a billion-year cycle, which would be a universe, say. So, however, the nature of evolution is such that this unit of consciousness, which I could call the monad or the quantum of action, as it evolves, increases the period of its time cycle and exercises choice within that range, timing that is. And as it later incorporates other things under as subsystems, it still times those subsystems to be in accord with what the whole organism wants to do. We'd have to learn this over a long period of time, and Fritjof's quite right that a whole lot of these reactions have, they're sort of automatic. But as long as you're in command of them, you can, let's say, speak English, which involves millions of automaticities that are functioning at your will, writing on the typewriter.
How do you distinguish control from velocity?
Well, it's the opposite, you see, and it's very interesting that acceleration is opposite position. I don't have a pendulum with me, but you can show that these things fall into quadrants. I first had bumped into it with the helicopter because the control was exactly 90 degrees out of phase with the force, and also the displacement. So the force and the displacement are opposite, but the control and the velocity you can say. See, this is partly arbitrary, but the important thing is to recognize the right angle between the control and the desired force. And I think that gets back into what we mean by right, because the right angle can mediate this. This gets, I'm sorry, it might be a little spooky, but I think it's rational. And it's able to deal with areas that we normally throw up our hands and say this isn't rational.
Certainly has to do with measure, which is the test of rationality. Well, we're about running out of time for the whole discussion. Is there anything?
Well, I want to thank Fritjof not only for coming, but for coming when he had a bad back.
It's a great pleasure. I think
yes,
it's an interesting idea.
Thank you for being with us. I
Why
really
not
enjoyed
drop
the chance
all
to
the
talk
lights
to you.
now and we can be like Haydn's Farewell Symphony.